Hi, in this video I'm going to show you how to perform basic statistical operations on the data in R. For example, if you want to calculate basic descriptive stat using mean, median, standard deviation, or if you want to calculate the percentiles, we can do that easily in R. For this, I'll start the script by declaring this particular command, which is as told in my previous videos, is to clear the environment of the R, and hit command plus return on Mac or control plus enter on Windows to execute a particular line. I'm going to import the data, and for this I'm going to first use a library which is open excel sx. Now if you are new to this video and don't know how to load the data in R, I have provided the link in the description, and the video is also available in the playlist. Now after importing this library, I'm going to declare one variable or data frame, data underscore my, and I'm going to read the file which is read.xlsx command, and this is the path to my file which I have already copied, and then hit command plus enter, and the data is loaded in R. We can click on the data and it is loaded as a data frame, and as you can see, if you just put your mouse here and the variable name is x, there is only one variable in the data. Now suppose if we want to calculate the mean of the data, I'm going to store it in a object data underscore mean. Just type mean and data underscore my, the name of the data frame, and put a dollar sign to give the column name which is x, and hit command plus enter or control plus enter on the Windows. The data mean is 43.5876. Similarly, we can calculate the data median by the command median, using the command median, and again data underscore my, that is the data frame name, and the variable name, put a dollar sign and type the variable name which is x. So the data median is 26.905, and if I want to calculate the standard deviation, suppose I'm storing it in data underscore st object, then just type st, which is for standard deviation, and similarly data underscore my dollar x. So the standard deviation of the data is 38.96970. If you do not want to write such as like data underscore my dollar sign and x, you can also use this command, attach data underscore my. Now by using this command, you just need to write the variable name, and let me rerun the program from the beginning. So it will still calculate. So it is up to you how you want to input the variable. The more on this is available in my earlier videos, and the links are given in the description, how to load the data set and how to extract the variables from the data set. Now suppose if we want to calculate the percentiles of in the data, then we can use the quantile command in R. To calculate the percentile, I'm going to first declare one object which is percentile underscore data, and using the command function quantile, we can calculate the percentile. First of all, we have to give the variable name which is x, and then we just need to write down at what percentile we need the data. For example, 0.95. So at 95 95 percentile we can get the data, and hit command plus enter. To see the output, you write print and the object name. So it shows that the 95 at 95 percentile the data is 109.966. Suppose if I want to see at 50 percentile, then I will change it to 0.50, execute this line and then this line. So at 50 percentile the data is 26.905. Now suppose I want to store the percentile value in a object, but not like this. It shows us 95 percentile what is the value. So what I can do is I can write this. So this actually, using this indexing, I can store just the percentile data point value in the object rather than storing like this. If you see over here, it doesn't store as a the data as a number like it has stored in mean, median and standard deviation. So to alleviate that problem, I'm going to use this particular indexing here, and now you see that the percentile data it has stored as 26.905. So suppose if I want to see 75 percentile, then again this is 84.8275. It will be stored as a number. So that is how we calculate mean, median, standard deviation and percentile in R. We can also calculate the interquartile range using IQR function. So I'm going to declare one object here, IQR underscore data, and the function that we'll be using is IQR, which is for interquartile range, all in caps. And it says what is the data. So the variable name is X, and if I hit command return or control enter on the Windows, it shows the IQR or interquartile range of the data is 75.4425. Now I will show you how to calculate the correlation between two variables in R. I'm going to delete this script and again start from the beginning, which is rm list equal, because I need to change the data set, so I have deleted all the script which I had written earlier. Again, I'm going to use the library which is OpenXLSX for importing the data, and I'm going to import the data and we'll be storing it in object data underscore my. The function to import the data is read.xlsx. Make sure this function corresponds or is from the it belongs to the library OpenXLSX. And then I'm going to paste the path of the data and hit run this line, and you can see that data has been imported. It has two variables x and y and has 8 observations of each variable. Now I'm going to use this command attach data underscore, so that I don't need to write again and again data underscore my $x or $y to indicate the variable. I'm just going to write their name x and y. Now after this, suppose if I want to find out the correlation between x and y. So I'm going to declare one object here, correlation underscore xy, and the function that we use to calculate the correlation is COR, this one, COR stats. And now just mention what are the two variables x and y. And if you see here, it also gives us a way or the options to choose which kind of correlation coefficients we want to choose, whether it's a Pearson, Kendall or Spearman. We are going to calculate simple linear correlation between x and y using Pearson correlation. So put comma, write method equals to, within quotation write Pearson. So it will calculate the correlation coefficient, which is 0.97222. And we can also do the correlation test or the test of significance of the correlation in R to identify whether the correlation is significant or not. For that, we can use the command which is cor.test. Now again, it is going to ask what are the variables. So the variables are x comma y, and you can just run this command. So it will calculate the correlation, and it will also conduct a statistical test of significance of the correlation. The null hypothesis here is that the true correlation is equals to 0, and alternate hypothesis is that the true correlation is not equal to 0. This is a p-value. So from this particular output, we can see that the correlation is 0.972208, and it is significant at alpha equals to 0.05. So that is how you perform basic statistical operations in R, such as calculating mean, median, standard deviation, interquartile range, percentile, and correlation between two variables. Stay tuned for more videos.